Good morning. I'd like to welcome you to our digital classroom. I'm Jerry Winslet, along with Mike Dial, and welcome to the monthly live show. For the past couple months, we've been having shows on NAECA III and how NAECA III affects the gas water heater products and the electric water heater products. And and there's going to be situations where you might the water heater that the NAECA III water heater might not fit in that location. For the most part, you're not going to see any issues like that. But there are some situations where that might come into effect. And this is really what this class is going to be about. We're going to talk about electric, going to talk about gas. But before we start, if you have any questions, you can use the chat feature, which is on the right-hand side of your screen. Just type in that question. After we're done with the show, what we're going to do is have a question and answer segment at the end before we sign off. So just type that question in if you've got one. But let's go ahead and get started. We got a lot to do today. We're going to talk a couple different products here. And what I'm talking about is, you have options whenever you have a new water heater. So in certain situations, you might run into a situation where the water heater's not going to fit, the new NAECA water heater won't fit, we may not even make it anymore.
Right.
And in electric, you might have to go with a different technology, and we're talking about this technology, heat pump technology.
Heat pumps.
And, let's talk about heat pumps. I know we make three different sizes, the 50, the 66, and the 80 gallon. How does a heat pump work?
Well, the key feature with a heat pump is we're going to use the air that's in the environment around the heater to heat the water. So
Okay.
we've got an air conditioner essentially here on top.
Okay.
So we're going to draw that air in, we're going to extract the heat into a cool coil, we're going to discharge some cold air, and that's a byproduct of the process.
Right.
What we're going to do is we've got another coil that's wrapped around the lower section of the tank, and it's a copper coil that's wrapped around and around, and we're going to shed that heat into the water. So it's a little bit slower, but it's really efficient.
So we're taking the ambient heat that's in the room and we're putting it into the water.
That's right.
Okay, all right, so it's very, very efficient. Now, this works on 208 or 240 volt, correct?
208 or 240 volt now, so depending on what your customer's needs are, we've got a variety of gallon sizes, and now we can work in every application, 208 or 240.
Cool, all right, so you've got, we're taking the heat from the air, we're putting it in, and you're talking about it being efficient. The EF rating on this is extremely high. And what EF rating is, it takes into account a few different things like standby heat loss, thermal efficiency, and it kind of wraps it into one number. And the higher the number, the more efficient the water heater is.
Yeah, in layman's terms, what it is it says it's a percentage of how much of the energy that we put into the product is turned into usable energy, in this case, hot water. So a normal electric water heater might be 0.9 or 0.95 efficient.
Right.
So 5% of that energy that we're using is lost out from standby loss or through insulation. With this, the EF is 3.24.
Wow. So you're talking about 3 times the amount as a standard conventional electric
We put
water
$1 worth of electricity in, we're going to get $3.24 worth of heat out.
Wow, that's incredible. So you're looking at an average savings of around $400 a year. And that's just the start. I mean, the larger the water heater, the bigger the heat pump water heater, the bigger the savings you're going to get.
Yeah, the more water that we heat, and we're heating it efficiently, so the more it gets used, the more savings there are.
Now, all right. So now we're talking about that's how efficient the water heater is. Now, let's talk about the hot water delivery. I know that this has the highest first hour rating on the market. With this 66 gallon tank, we're looking at around 80 gallons in our first hour delivery. Is there anything different other than, from a standard conventional electric water heater when it comes to heating water and delivering water?
Even though this has got a little slower recovery, that's the trade-off with the efficiency, we're still going to size it the way we would a normal electric water heater.
Right.
We want to size it for what our peak use is going to be. We want to have enough hot water for when everybody gets up in the morning and is washing their hands, taking showers, breakfast, or in the evening they're doing laundry, maybe doing dishes. So we're going to size it the same way. So we want to have as much dump load as possible for our peak demand.
Yeah, you were talking about this is a little bit slower recovery, though, than a standard electric water heater.
That's a little bit slower, and that's the trade-off with the efficiency, but
Okay.
The same way that we would size an electric water heater, we've got those long periods of time in between where we're going to recover, so it's not as critical for quick recovery.
Okay, and I know this has a fan on it, and I know that it does make noise. This is the quietest heat pump water heater on the market.
Absolutely. We've got the quietest. It's 51 dBA.
Okay, 51 dBA. And we looked up what 51 dBA was, and it was actually the sound of a quiet suburban neighborhood. So, as my boss Henry James says, this water heater is as quiet as the quiet suburban neighborhood you're putting it in.
Absolutely. It does make a little bit of noise. It's got a compressor, it's got a fan, so even though it is quiet and it shouldn't give you a whole lot of issues as far as noise, you don't want to put it in a baby's nursery or some place that's going to be adjacent where that noise might transfer and be inconvenient.
All right, now I know you've got a few different settings here. Let's talk about the settings. You've got efficiency, hybrid, electric, and vacation. What does it come shipped at?
Well, it comes shipped in the hybrid mode, and what that means is that we're going to rely heavily on the heat pump up top for most of our heating. But if we need quicker recovery, if we start to drop that tank temperature, we have the option of bringing on the electric element with the heat pumps to boost our recovery.
Okay,
speeds.
so if you're in a situation such as like family over or during Christmas, the holidays. You can run into a situation where you need more water, so it will actually use the heat pump and the electric elements in the hybrid mode.
Yeah, if we're marginally over what we might normally see, this is a good feature that will give you that hot water. It sacrifices a little bit of efficiency with bringing the elements on, but it gives you the hot water when you need it.
Okay, let's talk about efficiency mode. And what does it do?
Efficiency mode just runs the heat pump section to provide efficient, really efficient heating.
Okay. All right, and then that's just on the heat pump side. Now, on the electric, obviously, it's going to be your electric heating elements. Now, if I put it on electric and say I'm in a situation where I've got family over and I need the extra boost, so I put it in electric mode and I'm getting the benefits of that. If I forget about it, is it going to stay in electric mode?
It's not. So we know that this is a water heater that you purchased this hopefully for the efficiency, or maybe with NAECA, one of the benefits is the efficiency. So you're not going to get that just running in electric, but you might, like you said, if you have company over, you need more hot water. Everybody's trying to take showers on Christmas morning. So what it will do is after 48 hours, it will automatically switch back into that hybrid mode, which is the best mixture of efficiency and giving you the maximum recovery.
All right, that's great. Now, vacation, obviously, it's just you're gonna set it and go on vacation and leave it there, obviously.
You can program this for the vacation setting for the number of days that you're going to be gone. So
so then it'll pop back on there onto hybrid mode when you get back.
Yeah, so if you know that you're going to be gone for 14 days, you tell it you're going to be gone for 14 days. You don't have to get that rude awakening when you get up the next morning and get in that shower for work and you've got cold water. This will automatically kick back into the hybrid. Go ahead and heat that tank up for you.
All right, great. All right, so if I am, if I come to that situation where I have to have a different technology, this is a great option. As a homeowner, what do I need to have in order to have a hybrid heat pump?
Well, the key to the efficiency is having the heat in the air around it. So we want to have enough volume of air. So we recommend 700 cubic feet as a minimum.
Okay.
Now we can go down to 128 cubic feet if we make accommodations like a louvered door or louvers that are going to exchange air with another part of the home so that we can provide that heat into the air.
All right, and so I got to have enough air for the heat pump to work properly. Now, what about water? Is there anything I need to worry about on that?
Well, we've got a hot and a cold. Nothing has changed there.
Okay.
But it isn't. Air conditioning is a byproduct of the heat pump. So in air conditioning, we're going to condense water. So we do have condensate. So we're going to pipe that condensate to an approved drain or maybe to a condensate pump so that we can get it up and it's not flooding.
Okay. Well, what about maintenance on this? Is there anything that we need to keep in mind? Obviously, you've got a filter here. We're going to want to vacuum that from time to time.
Maintenance, this thing is really maintenance free. Really about every 3 months we're going to vacuum this filter. Now if we're in a dusty environment or there's a lot of lint maybe in a laundry room that might collect up here, we might do it more often, but that's really all the maintenance that we need to do.
Yeah, and you might want to check the condensate lines for blockages from time to time, just as needed, probably whenever you go ahead and clean that off. But it's a great option. It's an option that if you're in that situation where you need a new water heater, and that NAECA III water heater doesn't fit or we don't manufacture it anymore, you can look at going with a heat pump. And it's going to save you money because, the energy factor rating on this is the 3.24, which is extremely high. You're looking at 3 times the savings, 71% over a standard conventional electric water heater. It's a great option. But what we're going to do now is we're going to go over to the gas products. We're going to talk about the gas products. We're going to talk about actually a new tankless water heater, a condensing tankless water heater. But we got to walk over there. And don't forget, if you do have questions about anything we're covering here today, go ahead and use that chat feature, which is on the right-hand side of your screen. Just type that question in, and we'll get to it as soon as we get done with gas. So let's go over there. All right, okay. So we've talked about electric, the different technology in electric. Now let's talk about gas. There may be a situation where you're going to have to get, change technologies when it comes to gas water heaters. So we have, tankless, and we've been manufacturing tankless for a while. But usually you're looking at something like 199,000 BTU 540 model, which is right here. Now this is a condensing tankless water heater, but we're offering a new tankless water heater, which is actually 120,000 BTU, the 140.
That's right, and the nice thing about the 120,000 BTU is we can actually use that with most half-inch gas lines that are already in. So in a retrofit where you've got a half-inch gas line run,
yes,
this will accept the half-inch. With 199,000 BTUs, we needed a lot more fuel, so we had a minimum of 3/4 inch, and you really had to be specific. You might have had to do some resizing. So this is going to fit in a lot more applications.
Yeah, because it'll fit in with using the same gas line that you had before, which is it's just great in a situation where you're just pulling out an old one and putting in a new one. Now, this is a very efficient water heater. This is a condensing water heater. So we're looking at what are the efficiencies on this?
This one's in the low 90s, so it's more than 90% efficient. So a lot of the heat energy that we're from burning the gas is going into the water. We're not losing very much at all out of the flue.
Okay, so that's why it actually condensates. So we're putting that heat. That's why the vent temperatures aren't as high. We're able to use PVC pipe. If you look up there, we've got PVC pipe on there. And since they're not that high, we're putting all of that heat into the water so it cools those flue temperatures off. And we actually cool them off to where we're making rain and we have condensation.
Absolutely. Because we're using PVC, we want to keep those flue temperatures underneath 140 degrees.
Yeah.
The way we do that is really neat.
Yeah, that means my next, how does this thing work? Let's talk about that.
We're going to bring our cold water in here.
Yeah,
we'll get that out of the way. And we're going to go through our flow sensor. That's going to register the half a gallon of flow, 0.5 GPM that we need to get started. Then we're going to go up here to our secondary heat exchanger. Now, it's the first place we're taking the water, so why do we call it the secondary heat exchanger?
Yeah.
Because our primary heat exchanger, where we're burning gas here, we're extracting heat in this copper heat exchanger, so we're already cooled the flue gases.
Okay.
So to get a little bit more heat out of those flue gases, we're going to take those colder flue gases or cooler flue gases with the coldest incoming water, and gets us about 12% more efficient.
Yeah, so that's going to add to the efficiency on that water heater. I will have to put that back there. Oh, sorry. All right, so you've got 12% is being scrubbed off of this the secondary heat exchanger. So our water's passing through there first, going to our primary, and actually after it's running for a little bit, this will kind of preheat that water coming through the primary.
Kind of preheats it so that we've got warmer water hitting that copper heat exchanger, so that we don't have to worry about condensing with super cold water hitting that copper right away.
Yeah, and a tankless water heater is hot water when you need it. That's one of the things about it. When it will be in standby unless you turn on a hot water faucet. And this water heater needs to see 0.5 gallons a minute to initiate, to start up. So it's going to have to see that with the flow sensor. It's going to see that 0.5 gallons a minute. It's going to start running. It'll maintain around a 0.4 gallons a minute, but it needs 0.5 to see it. So it's only when you need it. Now, there's a difference between instantaneous hot water and, on demand. There's a difference.
Yeah, a lot of people might be under the misconception that this is going to provide hot water immediately when you turn on the fixture, and that's not the case. We still have to get the hot water from the heater out to the fixture, and this takes a few seconds, about 10 to 15 seconds, to start up and actually start putting that hot water out.
Okay, all right. Now, there are a few different things that kind of set us apart from other manufacturers of tankless water heaters, and that's kind of one of the things I wanted to talk about. The first thing is the air-fuel ratio sensor. Now it's also, obviously it's measuring the air and the fuel and making sure it's burning complete, but let's talk about that and kind of how that works.
Well, we want a good clean burn so that we know that we're getting efficient use out of the energy that we're putting in, burning all the gas and getting as much heat out of it as possible. So this is going to monitor that. We know what the combustion value should be based on our input, the computer board is monitoring their temperatures, it's monitoring how much gas we're putting in. If it doesn't see that clean combustion, this water heater will actually try to take steps. It will alter, it will improve, increase or decrease the fan speed to lean or richen the combustion to try and get that perfect burn.
So it's doing what it can. If you're in a situation where, you know, our gas isn't adequate, because you're looking at this, we got to have the right amount of gas. The gas pressure needs to be correct. You don't want to see any drops in gas pressure when the water heater starts. But if you're in a situation where it does drop some, this unit will do what it can to keep up, but it's going to get to a point when it can't.
It doesn't. Not every application or installation is the same, so the vent runs might be a little bit different. So this allows for that, the different friction for the air, and if we're marginally maybe just a little shy on our gas, it will overcome that. But if we get too far out of that range, it's going to let us know that it can't burn clean. It's going to give you a message that it needs to be looked at.
Yeah, it needs to be looked at. All right. So that's the air-fuel ratio sensor. We also have dual safeties. We were talking about it uses PVC pipe for venting. What other? Let's talk about the venting real quick, and then we'll get into the dual safeties.
We can vent with the popular is Schedule 40 PVC. Now you can vent with Category 4 stainless steel if it's required for some codes.
Right.
It's going to be a rare instance. Most people are going to Schedule 40. It's not terribly expensive. It's easy to work with, and it makes the job a lot easier to do when you're installing the water heater.
Right. Now, when we're using the PVC, we've got to keep those flue temperatures down. Now, these dual safeties, actually, that's part of its job.
Yeah, we've actually got several redundancies throughout the heater. This is a neat one. We've got a thermistor here that's actually measuring the temperature of those exhaust gases.
Exactly.
So if we get over 140 degrees, we start to run the risk of damaging that PVC, and that's not good. We don't want to leak combustion gases out into a living space or anything like that. So if we see temperatures that start to creep above 140 degrees, it's going to communicate back to the control board, and it's going to derate, or it's going to slow down the flow. It's going to do what it needs to try and lower the amount of heat being generated to lower those flue gases.
Okay, and that was on the thermistor. What about on the secondary?
In the off chance that the thermistor, for some reason, wouldn't be accurately reading those temperatures, and we actually are increasing those flue temperatures to a dangerous level, this high limit for the exhaust will open up at 149 degrees, and it will stop operation of the water heater so we don't have an unsafe condition.
All right, yeah, and typically whenever you're starting to see the higher flue temperatures, that may mean that the heat's actually not going into the water. You may have a blockage or something in your heat exchanger. It may need to be cleaned from time to time. But yeah, so we've got dual safeties here. We also have a special feature, or we have a feature on here. We've got freeze protection on this. So we don't always put these water heaters in, in southern Florida, where it's really warm. Some places it's colder. So, but we're looking for that. Now, let's talk about the freeze protection and how it works.
Well, first with freeze protection, you always want to take every precaution possible to prevent freezing. So you don't want to install the water heater in an area where freezing may be prevalent, where this could freeze.
Right.
We do have freeze protection though in these little yellow wires that go to all these little ceramic block heaters. They're positioned strategically throughout the heater to provide protection. At 36 degrees, we'll energize that circuit. Those will heat up, and they will prevent they'll prevent freezing from happening.
Okay. All right. And we're able to sense that temperature with this temperature sensor right here?
Yeah, this small black temperature sensor it's measuring the temperature of the cabinet. Now, when the heater's running, we're not as worried about it because we're providing heat. When the heater's in standby, though, if this cabinet, the area around all the water passages gets to 36 degrees, that's when we're going to come on and start to prevent
All right, so we've got the freeze protection, we've got dual safeties, we've got an AFR sensor, and this water heater is lightweight. When you're putting it on the wall, it doesn't weigh that much. Also, it's got a big cabinet, so you can get your hands in there and work on it if you need to. One of the things that we like to talk about as well, whenever you're putting in these water heaters, is a good option is to have isolation kits. You need isolation kits because from time to time you're going to have to do work on the water heater. You'll have to, de-lime it, you'll have to do any kind of maintenance on it. So you're going to have to be able to isolate the water heater. And if you don't have this, it becomes a problem a little bit.
It can make your job, it can make your day, especially after the fact, if you're doing service or troubleshooting, it can make it a lot more difficult. Now, we recommend, if you don't use the isolation kits, in our manual, we're still going to recommend that you have isolation valves and you're just going to pipe those in. This saves you from doing some pipe fitting and some sweating. It's all convenient right there. We've got a spot for our pressure-only relief valve.
And a pressure only, no temperature and pressure?
No temperature and pressure, pressure only, because we're regulating the temperature on demand as we're going here through
We're not
the heater.
storing any water either.
We're not storing any water.
Okay, so isolation kit is a must. We really need one of those if you're doing any kind of work, or excuse me, if you're purchasing one of these water heaters. I would purchase this with the water heater. It comes with it. But this is a great feature. This is a great option for somebody that's taking out an old water heater and putting in a new water heater. Maybe that water heater didn't fit. You can go with the 140 model, which is 120,000 BTU. We're able to use half-inch gas line, which is great. Now, is there anything else that the customer, what does a customer need if they are putting these in? Obviously adequate gas, but what do we need to look for if we're putting one of these in?
If we're putting one of these in, and another neat thing about this is 14 and a half inches from side to side. So
Small.
we're talking about space, and it's only about 50 pounds.
Right.
My recommendations for a customer, if you're going to sell this to your customer, we want to make sure that we do direct vent that, and we take the combustion air from outside. With new homes and tighter construction, air might be a little harder to come by. So if you take that and get that combustion air from outside, you don't have to worry about it.
Yeah, that's where you really want to, because if you stick it in a laundry room or something like that, and you're using room air, you run the risk of the lint and dust. And you do that with any water heater, any atmospheric water heater that's not direct vented.
One more thing is that it is condensing. So you see we've got an extra pipe that's coming down here off of the bottom. And it's in PVC. So we are condensing. It's a byproduct of combustion, flue gases.
Right.
So it is acidic. So we need to dispose of that in a safe manner. We don't want to take it into a metal drain. Now, if we have to take it into a metal drain, we do offer a neutralizer kit that will go in line there, and it's got a media in there that takes that acidic pH down to a more neutral pH.
Now, let me talk to you about that, because this is not like the condensation on the heat pump. Yeah. This is actually acidic, because this is the flue gas is actually turning in to liquid. So those are acidic. So you wouldn't want a nice shiny copper line. You'd want PVC.
Yeah. Not for the condensate line. A nice shiny copper line, it looks great for an installation, but the acidity in the condensate will actually eat through that in a short period of time.
Right, and when you're dealing with condensation on either product, always adhere to your local codes on disposing of that condensation. But this is just another option. Another thing I want to talk to you about is the controller. It's easy diagnostics, and this is actually built-in diagnostics. This comes with the unit, correct?
Yeah, this comes with the unit on the indoor units. Any of our current production condensing heaters, so the 140, 240, 340, and 540, they have a built-in control. What's really neat about this control, and I think we can, even with it in standby, makes it easy for me to adjust the temperature. Okay. So I don't have to get in and worry about dip switches and maybe hitting more dip switches than I need to. I've got big fingers like I do. Now it does come, this one capped at 120. If we need temperatures above 120, there is a method that we can do and override that. So we know that not everything is a one-size-fit-all if you need sanitary for dishwasher or something like that. But 120 is where it comes from the factory, and that's what we'd recommend, and if you need to go over that. Another neat thing, and I really like this, having been a serviceman out there in the field, when we press that info button, I can immediately see what my inlet temperature is. I can see what my outlet temperature is, and it'll take a second to search that.
But so we're sensing temperature all over this thing. So we've got an inlet temperature and an outlet temperature. And actually, we don't have this hooked up to water right this minute, but it is saying it's 77 degrees. So it's
and that's our ambient temperature in here. We can also see the flow. So really quickly, I can see what the flow is and what my temperature rise is, and that helps me in some certain cases to be able to diagnose.
Okay. Now, easy to understand too. It also comes with, you can have error messages on this as well.
Yeah, you can have error messages on this. Now, some of them are hard lockouts. Most of them are going to reset as soon as you turn the water off and into a cycle for heat. So there's a function on here that gets into an advanced diagnostic menu, so we can look and see what the last 3 errors were.
Great.
So when the customer says, hey, it stopped while I was in the shower and I went and nothing was fine and now it's working, you can look and see exactly what happened during that cycle for heat.
All right, great. Well, again, this is the 140 unit. It's 120,000 BTU. It's a great option for you if you're in a situation where you have to change technology, where you have to go from either we didn't have the water heater or that NAECA III water heater is just not going to fit in there. Go with 140, and again, with tankless, it's all about how you use water too. So sizing is important when it comes to these.
Sizing is important, and one of the things that we're going to be looking for is what's our maximum flow that we're ever going to need at one time, and then what's our coldest incoming, so
Exactly.
wintertime coldest incoming water temperature, and then what's the warmest temperature that we're ever going to want to deliver at. So if we were in Texas in the summertime, we wanted 110 degree water delivered, but our incoming water temperature might be 95 or
Right.
even 100 degrees. There is a minimum temperature differential that we're going to look for because it's a minimum BTUs, 15,000 BTUs. So we want to make sure that we're going to generate enough demand to justify 15,000 BTUs.
Yeah, because it ranges anywhere from 15,000 BTU up to 120,000 BTU. All right, it looks like we got a couple questions already. So the second one there is, can you only drain into a PVC drain, not metal?
It doesn't have to necessarily be PVC, but it cannot be metal for the condensate because of the acidic nature, unless it were a stainless steel drain, which prices it out of motion range. But you could use silicone tubing or any other material that's going to be appropriate for condensate.
Right, and also you always adhere to your local codes, whatever they're telling you, you cannot do, then adhere to that.